We're on problem 77 of chapter 2. Problem statement. A circle of unit radius is etched on a plate. The plate is then subjected to a homogeneous deformation that stretches according to the following map. Phi of z equals 2z1 e1 plus z2 e2 plus z3 e3. Find the expression for the stretch of the line under the deformation map as a function of theta, and find the length of the etched line in the deformed configuration. We're also given the problem figure as shown. First step of the problem is to find the normal vector, unit normal. At theta equals 0, we see that that vector is equal to e2. At theta equals 90, that vector is simply negative e1. Combining those two results, we deduce that that vector must be negative sine theta, cosine theta, and 0. The next step of the problem is to find the tensor of the gradients. To find that, you just differentiate phi of z with respect to z. And when you do all those calculations, you get 2, 0, and 0 in the first row, 0, 1, 0 in the second row, and 0, 0, 1 in the third row. Next step, we need to find the tensor C. That's simply F transpose multiplied by F. Matrix multiplication gets you 4, 0, 0 in the first row, 0, 1, 0 in the second row, and 0, 0, 1 in the third row. Next step, we find the square of the stretch in the n direction. To find that, you simply take n dotted with c operating on n. When you do those calculations, you get 4 sine squared of theta plus cosine squared of theta. If you want the stretch in the n direction, you simply take the square root of that. That's root 4 sine squared theta plus cosine squared theta. To find the length, we want to integrate that stretch that we just found from 0 to 2 pi, which is the original length. So we have L equals 0 to 2 pi, root 4 sine squared theta plus cosine squared theta d theta. When you do that integration, you come up with 9.688. So we have an answer of 9.69.